Hey everyone, my name is Jeffrey Falkinburg and I'm a professor here at UNL in the School of Computing. I'm excited to be able to sponsor our fourth year of the Husker Scope project. The project this year will again be more hardware focused, and what you will build will benefit engineering students and faculty throughout UNL and around the world by providing a useful piece of test equipment. The Husker Scope app is an all-in-one cross-platform app, so iOS, Android, and web app application that implements a dual channel function generator, AM/FM modulator, oscope, and spectrum analyzer functionality for use within UNL engineering courses and around the world. The Husker Scope app primarily interfaces with other devices and test equipment through a 3.5 millimeter audio jack cable and are limited to the audio frequencies and low voltage applications like what I use in my Advanced Embedded Systems course. This year for Husker Scope, we are developing a more advanced dual channel oscope and spectrum analyzer functionality. We're going to be doing this by continuing development of our hardware interface using multiplexing to digitally merge and transmit the two channels of the oscope and spectrum analyzer to the app via Bluetooth. We're also going to be setting up and testing Bluetooth transmission speeds to ensure we have adequate throughput. Otherwise, we may need to research and consider a Wi-Fi interface to increase that throughput. We're also going to be developing a new PCB design to enable those two ADC inputs through the BNC connectors at 1 to 10 million samples per second and enough RAM to store two buffers of 1 million to 10 million bytes each. We're also going to be developing a multi-channel logic analyzer functionality. There's already a basic functionality built, but we're going to be modifying that interface to merge those 8 digital inputs, being able to store 1 to 10 million samples per second, and being able to transmit that via the Bluetooth to the apps. So we'll need to have enough RAM to store those bytes and samples, and then we'll also look into being able to implement different protocols that you can find on SIGROC to be able to look at the signals and analyze them based on PWM, SPI, UART, and timing and that sort of thing. This currently is the state of the PCB. It will be modified this year, but it's at least a start. This application will be used by engineering students and faculty throughout UNL and around other colleges and universities around the world. I am the principal investigator and will be your primary contact. The ultimate goal of this project is to build and test new hardware input interface to our Husker Scope app, as well as add in more capabilities into the app to support students in our engineering courses, especially Advanced Embedded Systems. To give you a little background on me, I've been teaching in the School of Computing for 6 years, and in that time I've been a senior design tribe lead and sponsor for many senior design projects. I also teach courses like computer organization, where students learn how to design and build the NIOS processor on the DE10 Lite FPGA. Additionally, I teach embedded systems, where students learn how to build the drivers on an Arduino to interface with things like buttons and switches, LEDs, servos, and motors, and eventually they learn how to drive a robot through a maze. We also learn how to interface with an LCD and joystick to be able to create a digital Etch-a-Sketch and a retro Pong game. Lastly, I teach Advanced Embedded Systems. I've taught that course here for 5 years now, and I've taught a similar course at the Air Force Academy for 2 years prior to that. This course teaches engineering students how to develop the hardware and software interfaces for an oscilloscope and function generator using the Nexus Video FPGA. These students will be continuing to use and test our Husker Scope app in the class. In the first 3 labs of this class, students learn how to design on an FPGA the OScope display and be able to output that through the HDMI port to an actual display. Next, they learn how to take the audio left and right channels and display the input waveforms on the display just like shown here. Finally, they learn how to drop in a soft-core processor onto that FPGA to design other processing capabilities into that waveform that's coming in to be able to modify it before it's displayed. In Lab 4, the students learn how to build a function generator that generates waveforms that they can display on an oscilloscope. The problem we have is we have a lot of single function free apps available on Android, but there's limited free apps available on iOS. And there's no real multi-function and cross-platform apps. Also, our microphone input limits the input voltage range and the frequency of our system. So our solution is to expand the all-in-one cross-platform app so it can accept multiple inputs to analyze analog and digital signals outside the standard audio range, which is 20 hertz to 20 kilohertz. This interface shows how the function generator and the OScope apps on Android, iOS, and web app interface through the 3.5mm audio jack to the Advanced Embedded Systems students' designs on the Nexus video board on the right, where they're displaying that data on their OScope or outputting the data to the OScope. These designs interface through that standard stereo audio cable port that's on a phone or a computer. This diagram shows the typical pinout of a 3.5mm stereo audio jack with the left and right channels, left and right, and even shows the microphone input for the oscilloscope application on the phones. Since many phones these days are removing that native 3.5mm headphone jacks, some of the phones will need a USB-C or Lightning charging port jack adapter to interface with the app. Currently, in order to get the mobile and web apps to allow for that external microphone input for the OScope input and be able to use the output function generator from their design and be able to switch those, students had to build a small hardware interface that takes the left and right channel. You can switch between them, and it also divides that signal coming into the microphone input on that audio jack. Students also prototyped a breakout board where students actually use this in the classroom for Lab 4 to be able to bring in their function generator waveforms and display that on the apps. If you're interested in creating this year, we would like to continue development on that hardware interface for dual channel oscilloscope and spectrum analyzer functionality, multi-channel logic analyzer functionality, as well as increased sampling rate and increased number of samples, as well as configuring and testing that high-speed Bluetooth interface to the app on the current hardware interface. If you're interested in creating an all-in-one cross-platform test equipment to aid engineering students or interested in software and hardware-driven project, please join us on the Husker Scope app. I hope you decide to join us on the Husker Scope team and continue with the excellent work of the 3 previous senior design teams.